Conference report. What I don't get is that when you're reporting that your experience as a mind doesn't involve indeterminacy, it seems like a Newtonian world. That's just does not seem to be the case to me. That's an illusion that you've taught yourself, perhaps, because you have faith. You know, as intelligent little children, we're the kind that see something confusing and some enigma, and we figure it can be explained, and often it can. Okay, so inductively we think everything can be explained, and then we start acting like we're in a world where everything can be explained. But we don't explain everything. We don't have determinacy in our actions. We waffle and wonder, and you say that the will came out from trying to process information, this basically Newtonian machine processing information, trying to. Try. What tried? Newtonian machines don't try, they just do, right? A computer has behavior, but it's not trying, it's just doing the thing, right? It's just doing it. It just behaves. There's no, what is it try? Why would a deterministic thing have a concept of trying? It would just, here I am, I'm doing it. It wouldn't have to try. There's nothing to try because you can't succeed at trying anything because it's determined what's going to happen, and trying wouldn't play a role. And this is what I'm pointing out. We have all of these terms that we use, including the people that don't believe in free will, that are based on will and based on the fact that there's actual decisions to be made. But I mean, I'm okay with your view because you're just saying, well, there is indeterminate physics, but it doesn't play a role in the brain. And that it plays a role in the brain, but it doesn't play it doesn't have it's a negligible role, you know. And that's okay because at least you're not denying that quantum mechanics applies. I mean, there's one guy in a comment said the uncertainty principle doesn't apply at the macroscopic level. Nobody says that. What? It applies everywhere, all the time, everywhere. Everywhere. No, it's not like there's nothing in the equation that says, and then at this scale it doesn't happen anymore. No, it's just then at this scale the effects become negligible in most cases because of random distributions. So the one thing that's funny is that people think that if quantum mechanics plays a role in the brain, it's just to make it all mush and random. No, that's not what it would do. It's like quantum mechanics in photosynthesis. It's done not to, I mean, everything already has a random distribution and you don't get a benefit from quantum mechanics. When you start lining up the states, it'll be to get a benefit, not to get something more chaotic, but actually to eliminate the chaos. How could that be? Because if you just accept that things are probabilistic, there's some amazing, powerful games you can play with probabilism. Okay, amazing. Okay, so things like getting a solar collector that's 98% efficiency, not classically possible. It is in quantum mechanics, because quantum mechanics does not make the world harder to manage once you find out everything's random, we won't do anything. No, because randomness has to do with probability, and so as long as you can get millions of objects, you can start filling out the probabilistic distributions, and because they're waves, you can overlap these wave functions. You can overlap things in space so that the field has interference in various patterns, allowing you to really control the shape of that distribution. So you can make a big spike. You can make something that's normally just unlikely to happen out at the wing of a bell curve. With given enough events, knowing their probable shape, their wave function shape, and overlapping them in standing waves and various, wave physics tricks like that, then you could create where there was a little low probability wing. You can make the spike of probability there and make an improbable thing happen. And why would we not exploit that evolutionarily like we have the other physics? Why would we have stopped with Newtonian physics? Just the physics we happened to discover when we first discovered physics for real and really got going. That's the only physics our biology discovered. Well, we know that's not true because it uses the photoelectric effect and things that aren't well explained in classical physics. And Yeah, I don't think our biology was studying physics and only got up to Newtonian physics and then had to stop. It's very opportunistic. It's very trial and error oriented. And I think that you guys should take into account the presence that has occurred in the last few years, the apparent presence of quantum mechanical biology in photosynthesis.